On behalf of the Fort Worth Museum of Science and History, I would like to welcome you to the Research and Learning Center. We are delighted that you came out on this rainy day to join us for actually what is a historic event, the first annual TCU College of Science and Engineering 3-minute thesis competition finals. We are really excited to be your hosts, especially since the 3-minute thesis is right in line with the goals, the main goal of the Research and Learning Center, which is to bridge the science communication gap between researchers and the public. So if you are a researcher, we invite you to consider bringing your research to the Research and Learning Center, setting up your study on Saturday. If you are a museum guest, we invite you to come by on a Saturday and learn about what's happening in current science by being a part of one of the studies. If you have questions about the Research and Learning Center, we have a table set up at the back with flyers that have our recent studies, or be sure and ask me if you have any questions about it after the competition. I would like to recognize and thank the visionary behind the project, Dr. Magnus Ritby. Actually, he's more than a visionary. He's pretty much single-handedly undertaken this initiative, and he's put a lot of initiative into getting it started, gathering resources and support, and just all the time and effort that he's put to get this together. And it's all in his quest to improve science communication. So we're glad you're here today. We hope you enjoy your time at the Research and Learning Center, and we'll let Dr. Ritby tell you about the events for the day.
Thank you, Debbie. I've never been called visionary before. I've had a couple of visions, but not. Okay, yes, as Debbie said, I am Magnus Ritby. I am the Senior Associate Dean in the College of Science and Engineering at TCU. I see a lot of familiar faces, and I see some unfamiliar faces. They're still friendly faces, that's good. And this is sort of an idea that came from me seeing Debbie present something at TCU, and we started chatting about the possibility of having the college collaborate with the museum in a variety of ways. We already do, actually. We have, for example, we have our chemistry club of students come here and work with the patrons of the museum now and then, during chemistry week, for example. But we want to try to engage a little bit more with the museum and hope to attract the public in and connect with us at TCU and our brilliant students and our not so brilliant faculty. Did I say that? I'm going to regret that, I think. As Debbie pointed out, this is part of our effort to help our students and our faculty and me to become better at presenting research to the public. And the 3-minute thesis competition is something that started a few years ago in Australia, actually, in the University of Queensland. And it's now spreading around the world, and more universities are picking up on this and using this as a vehicle to encourage students to practice presenting their research to the public, and in this competitive way sort of drive them hopefully to practice and do this in other venues. And this is the first time when we are venturing outside of the TCU safe zone where we're all academics, and we try to go on the road, so to speak, to take the 3-minute thesis on the road and subject ourselves to whoever wants to show up. So we'll do more of this sort of thing. So the key here for the competitors is to explain their research, their graduate research, not completely, but give you a flair of what their research is about in 3 minutes with one PowerPoint slide. I apologize that it's a little bit dim here, the slides, but that's going to be okay. They're going to be shining students in front of you. You're going to forget all about this slide. So there's 2 areas on which our 3 judges will be judging the presentations, and as well as you will be judging the presentations. You'll find, hopefully you found on your seat, if you don't have one of these, I have extra copies up here. This is the public's choice ballot for the presentations. And all I'm asking you to do is once we're done, don't start tearing after the first presentation, which will be great. Don't make a mark, but wait until all the presentations are done. And then just mark who you feel made the best impression on you in terms of presenting what they did. And just look at the dotted line for each person, and you just pick the dotted line and you make a tear on the ballot at that line. Not like that. Actually, you could do it like that. It would work too. Just we'd have more paper to do. So just make a little notch. So here are the two areas, comprehension and content. So it's basically, did you understand what the research is about? Did you get sort of that general idea? What is it that they're trying to find out in the research project? What is the key finding that they're looking for? What maybe is the key finding that they already found? And is it communicated in language appropriate to an intelligent but non-specialist audience, right? So this is where we have the most trouble as scientists, is that we have our own language and we have mathematics and we have terminology, and when we talk to the public, sometimes we get caught up in using this language, and then it's hard for other people to understand what we're trying to say. So that's the key thing. And another part of it is that we suffer from the curse of knowledge. That is, we think we know a lot. We've worked a lot on trying to understand some little small piece of nature. And the curse of knowledge just is the curse that it's hard to get out of that little hole that we've dug ourselves into in our knowledge space, and then try to come out and tell the rest of the world what we found down there. The other area is engagement and communication. That is, how engaged is the presenter with the audience? Are they facing you? How well do they connect with the audience? So those are the two. The judging panel will score those two categories independently. You will just kind of look as your general feeling of how it is. So you only have to make that one notch. We have 3 judges, 3 esteemed judges, 3 people that I call friends. I'm not sure if they will call me a friend, but I call them friends. Bill Bennett is a member of our college external advisory board and has long experience in the biotech industry, and he is our, I would say, representatives from the outside world of TCU and where our students will go in the future when they start being employed, and he can judge from his long, vast experience from industry. Romy Hughes is an assistant provost at TCU, and she's also, are you still the director of the Kaler Center?
I'm just the assistant provost.
Oh, okay. But she leads the Kaler Center for Teaching Excellence. So that's a center that works with our faculty to help them with techniques on how to improve their communication in the classroom, for example, to students. And Molly Weinberg, who is the Adams Chair of Education in our College of Education, and she's also director of the Andrews Institute for Mathematics and Science Education. And Molly works a lot with teachers, K-12 teachers, and helping them in terms of their skills to present or work with students in their classrooms. So that's their backgrounds to give you very qualified judges to judge this competition. And then, of course, you are the other group that is qualified to judge the competition, maybe the most important, actually. Okay. Amanda Hale is laughing, but so phones, right? Phones. Almost all of us have them. These smartphones. I don't know if they're very smart, but you know, we call them smartphones. They're smarter than the phones that we had before. But if I would want to explain to you what a phone actually is, I could do it this way. I could break it apart, or my son would break it apart for me. and then look at all the individual pieces and try to explain what each of those little elements inside the phone actually work, or what it's doing. Or I could even go further. I could go and analyze what, it's hard to see on this slide, but what natural elements from the periodic table do I have to include in order to make a smartphone? It turns out that there's lots of things I could say about a phone that you wouldn't really care about because you just want to make a call or make a text message. So the curse of knowledge is an example of, if I was a telephone or iPhone designer, I would have all this knowledge, and if you asked me what a phone is, I would maybe start telling you about all these intricate details which you wouldn't really care about. So instead, you just want to know this, which button to push to get the action that I want. So there's a special button to push, which is the silencing button, or off button. I would ask you that you check that your phones are silenced at this point, because when the presenters start, we don't want to have interruptions. You will be immediately evicted by the security guard in the back. I win. So, we're about ready to go. And we're going to go in the order that you have on your little scoring sheet there. And we're going to start with Cecily Fu. And she will tell us about, she's a second-year master, yeah, you can go up there, that's okay, we can look at you. A master student in the Department of Biology, and I've seen at least one of her advisors, maybe two, both of her advisors are here, Dr. Tori Bennett and Dr. Amanda Hale. And she's going to tell us something about bats. So we'll start whenever you are ready. I'll put up your slide, and then you're ready to go.
We need clean, affordable, renewable energy. Wind energy is a great option. Right now, one of the biggest rate-limiting steps in the expansion of wind energy is bat mortality. And initially, scientists thought that birds would be hit the hardest, pun intended, by wind energy. But it turns out that bats are actually being killed in much higher numbers. So hundreds of thousands of bats are being killed at wind farms every year. And we really don't know why. This is important. We care about this because we don't know very much about bat populations. They're really small, a lot of them are migratory, and they're really hard to track and study. But we know that they're important to the environment and to the economy. So bats save the agriculture industry $3.7 billion a year in pest control by eating moths that would produce caterpillars that would destroy crops. So this is something that we actually really care about. We know that bats are dying at wind turbines, but we don't know why. And this is a problem that the Bat Lab at TCU is investigating. So the aspect that I'm looking into is I'm trying to see if bats are coming into contact with wind turbines because they're feeding there. So TCU conducts research at a wind farm in North Texas, and we've been doing insect trapping there as well as bat fatality searches. So I'm looking in to see if there's a relationship between the insects that are present at the wind farm and the insects bats are eating. So the insect trapping that we've been doing, we basically go to the turbine towers at night and we trap insects. So I'm seeing what populations of insects are there based on that information. And then with fatality searches, we go out and we pick up bat carcasses that have been killed at the wind turbines. And then I bring those back to the lab and I dissect them and I take out their stomachs and I do a genetic analysis to see what species of insect they're eating. So by comparing the results of that genetic analysis to the insect surveys at the turbines, I'm trying to figure out if there's a relationship between those two populations. This can tell us if bats are in fact coming into contact with wind turbines because they're going there to feed. I don't know if you've ever worn a white t-shirt outside at night, but you pretty much turn into a bug magnet. So we know these bugs are there, and I'm just trying to see if it's the same species. And hopefully this will tell us if that's why bats are dying. And if it does, we'll be able to use that information to do further research in order to minimize the insect populations at wind farms and minimize bat fatality in order to allow for continued expansion of the wind energy industry.
Thank you. Okay, great. On here. Okay, our next speaker is is from my own department. That's I'm not judging, so it's okay. John Donor is second year. He's in the PhD program in the Department of Physics and Astronomy at TCU. And his advisor is also here. Dr. Peter Finchabo is about to catch a flight, so I hope you can stay for the whole 3 minutes. And he's going to talk about star clusters. Oops. Bear with me. I'm ready when you are. And you can have your slide.
I study stars. More specifically, I study star clusters, groups of stars. Now, astronomers really like star clusters because they turn out to be very useful for us. See, all of the stars in a cluster form from the same cloud of dust and gas at about the same time. So not only are they all made of more or less the same stuff, but they're all about the same age. And while that might sound like some sort of first grade fun fact, when you're trying to study the evolution of the galaxy, you have to know how old stuff is. Fortunately for me, all of the stars being the same age also makes the clusters really easy to model. So astrophysicists are very good at modeling the evolution of a single star. So if we want to model an entire cluster, we just have to model a whole bunch of different stars of different masses. Now, as you may have guessed, one such model is shown behind me, frozen at a point in time and overlaid on top of a real star cluster. Now, some of you may also notice the axes on this plot, color versus brightness. And what that could tell you is that in order to get all of this information about the cluster, all we have to do is take a couple of pictures, which makes this technique even more powerful. Now, you'll also notice that the model fits the star cluster very well. And that's not a trivial thing. We spent all summer developing a computer program to fit these models to star clusters. And the way it works is by testing models evolved to all kinds of different ages and trying to find the one that fits best. And in that fitting process, it also determines how far away that star cluster is. So when we're done, we know not only how old that star cluster is, but basically where it is in the galaxy, which makes this technique very powerful for studying galactic evolution. Now, you might be wondering, why has nobody done this before? It doesn't sound that hard. Surely this kid standing in front of us is not the only one who can write this program. And you would be right. But the problem is, in order to choose the model that fits the star cluster, you have to know the chemical composition of that cluster. These models are very sensitive to the initial chemicals in that cloud of dust and gas. So if you don't know those chemicals, you can't choose the right model. At TCU, we have access to the Apache Point Observatory Galactic Evolution Experiment, or APOGEE for short, quite a mouthful. So with APOGEE data, we have access to chemical composition for over 100,000 stars. So if we want to study a star cluster, all we have to do is find one apogee star in that cluster, and we can choose the model that fits that cluster the best. Using this technique, we will be able to study hundreds of clusters, which makes the scale absolutely unprecedented in astrophysics research. And at the end, we expect to have a much better understanding of the evolution of the galaxy. Thank you.
Managed to talk about that without mentioning Star Wars or Star Trek or anything. That's impressive. Even I thought it was going to be a Star Wars reference. Galaxy far, far away. You know.
We got to learn about our own first.
That's a good point. That's a good point. Our next speaker is from the Department of Psychology, Megan Pruitt. Hold your applause until after the talk, please. Thank you. And she's also in a PhD program, a third-year student in a PhD program in the Department of Psychology, and she will talk about autism research. Give me a moment, and I will pull up your slide. Is Dr. Ekas here, by the way? No.
She's out of town.
Oh, she's out of town, okay. Ready when you are.
All right. 1 in 68. This may seem like just another number. Just another statistic. But what if that one was your child? What if your child was the 1 in 68 children diagnosed with autism spectrum disorder? If that was the case, this would no longer be just another number. This would now be your life. Autism spectrum disorder, which you're also going to hear me just refer to as ASD, is when a child has difficulties interacting with other people, communicating with other people, and has a really strong preference for routine. Because of these difficulties, it makes it very hard not only for the child, but for their mothers as well. And mothers often report lower well-being, difficulty interacting with the child, and that it has an impact on their family. But how do we really understand what is going on in these mothers' lives, and that's leading to these outcomes? Well, in my research, we used a new method called daily diaries to look at what's going on in these mothers' lives on a day-to-day basis. We had mothers fill out questionnaires about the types of symptoms of depression they feel they experience, how severe they feel their child's ASD is, and also how they feel their family is functioning. As part of this daily diaries part, they reported on their daily good mood, daily bad mood, positive parenting experiences, and frustrating parenting experiences. So what did we find? We found that although parent and child characteristics are related to daily mood, when it comes to parenting experiences, the family is especially important. Specifically, when parents report having positive parenting experiences, they feel that their family is more cohesive, which means that they are appropriately involved in each other's lives, they're supportive, and they're flexible. However, on the other hand, when they report that they're having frustrating parenting experiences, their families aren't functioning so well, and they're also reporting that they're experiencing more symptoms of depression. So what does this all mean? Well, first of all, it does appear that although there are risk factors associated with having a child with ASD, like mental health and family impact, that it is possible to have positive experiences as well. Specifically, when it comes to parenting, it appears that the child's ASD is not directly leading to these outcomes, but rather the family context and the mother's personal characteristics themselves. So what do we do about this? This means that we need to support these mothers and children with ASD. Because if you can imagine, as a mother, if this was your child, that you are probably trying to do everything in your power to make sure your child has the best outcomes possible. But this research shows that we really need to make sure that these mothers are supported in doing this and that they're getting taken care of as well. So how do we do that? We need to create more family-based interventions so that we can directly teach these families how to be supportive of one another and especially be supportive of these mothers. With the rates of ASD recently increasing from 1 in 88 to 1 in 68, that means more and more families are going to have to learn how to live with ASD. But that's not the point. We don't want these families to just be able to learn to live with ASD. We want to do everything in our power to help them live well and have the best outcomes for both their child, the mothers, and the family. Thank you.
You notice that our college is, we span a lot of different disciplines, right? From psychology, we heard about autism, and we heard about looking out into the galaxy and understanding the evolution of our own galaxy, and we heard about bats and wind energy. So that's a challenge sometimes for us in the college, but it's also a great asset for us to have this diversity of students. The next speaker is Christina Biens. She's in the School of Geology, Energy and the Environment, but she's an environmental science master student, second year, and the same advisors as we had from our first speaker. And I will get all the stuff ready and get your slide up, and I'm ready to go when you're ready.
There are hundreds of thousands of bats dying in wind turbines each year, and we really don't know why. And this is alarming because, in reality, we don't have a good grasp on how large our bat populations actually are to begin with. And these species provide us with several services. For example, they provide $3.7 billion worth of pest control to the agricultural industry each year. So if there are significant decreases in these populations, will have significant impacts in other areas of our lives. Some researchers have looked already into why bats are coming in contact with wind turbines, and they have proposed that bats may be attracted to the wind turbines. In other words, they may be interested in the noise or the movement of the blades, or they may perceive or misperceive the wind turbines to be resources. Some studies have shown that bats perceive or misperceive smooth surfaces such as metal, plastic, or wood
to be water, and they attempt to drink from these surfaces. Other studies, a student from TCU, saw that bats are approaching wind turbines with the same posture that they do when they drink at other water sources, such as cattle ponds. So we wanted to look at this a little bit further. So my research looks at, are bats actually drinking at wind turbines? And if so, can we identify a surface texture where they show little or no interest in approaching? So in order to accomplish this goal, we built a flight room here at TCU so we could bring the bats closer to us. And in this flight room, we included a replicate of a wind turbine tower, so a smaller section. And we equipped this flight room with cameras that give us high-quality images in low light. And we also have high-speed cameras that basically allow us to view bat behavior in slow motion. So then we went out to local parks around Fort Worth and caught bats and brought them back into our flight facility. Then we observed their behaviors at each textured surface each night. So what have we found so far? Well, we have seen that bats are attempting to drink at this surface, which is equivalent to a wind turbine tower. And then we've also identified 3 textures that they have not attempted to drink at, and they've shown little interest in. But we need to look at the data a little bit further to see and identify which textured surface they show the least amount of interest in. Once we have identified this textured surface, we can then apply it to wind turbine towers, which we hope will ultimately decrease bat fatality each year.
Well, another reason to hold this competition here in a different venue from TCU is that you have to be able to adapt to someone playing a piano behind you. It's not so easy. It's a less control environment than what we're used to, but that's part of what we're trying to do. Okay. Our next speaker presenter is another student in my department. Again, I'm innocent in selecting the students. And Han Guan is also a third-year PhD student, and he works with Dr. Carol Brzezinski. And he will talk to us about something related to cancer. We'll see what that relationship is. And I'm ready when you are.
Ready. Last century, having the beauty mark of Marilyn Monroe is defined as a Hollywood blessing. Nowadays, people realize that if you have most of fracture into the body, it's not always a good sign, because it's a sign that shows that you might develop skin cancer. Skin cancer, number 6 most common type of cancer in the U.S. 1 in 50 American people were diagnosed with skin cancer at some point in their life. I'm particularly interested in the type of skin cancer called melanoma. It is the least common type of skin cancer, but it's the most lethal and leading cause of death. An approximation of 100,000 Americans will be diagnosed with skin cancer. 10,000 of them would die in 2016 in U.S. alone. That made 1 person die every hour as we talk. The problem because they don't have early diagnosis enough. So the name of the game is early detection. Be able to distinguish melanoma from the other type and to treat it. Early detection requires regular checks-up. Here an example of a check is the mode of my advisor uses a cell phone camera. Well, but to treat it or to classify them is still an ongoing process that I set to solve. My PhD project focused on working with molecules called dual porphyrin as a future drug in treating melanoma in photodynamic therapy. It is 2 molecules of porphyrin linked together. Now, why do we care about porphyrin at first? Because it's in our blood. It's in the plants. It's everywhere. And here at TCU, we make it and we're studying it too. We can attach these molecules into the tumor, and as we shine the laser beam to it, it will interact with the oxygen molecules inside our body. It will turn that normal oxygen into a super oxygen, as known as singlet oxygen agent, that can bleach and kill the target tumor. Furthermore, to improve early detections, our current funding allows us to acquire a new camera. It will claim to be the fastest camera in industry that can collect 1 billion frames in 1 second. Let me be clear, 1 billion frames in 1 second. Having this ability, our new idea is to attach this molecule to the most of our tumor. And then we turn on the laser through the camera, everything will be visible. T is the one that with the dual profit, and the C and U will stand for the local tissue. But the light emitted from the local tissue will be fade out after a short amount of time. So by collecting all the frame at different times, we can selectively pick up the frame where we can only see the tumor itself, what I call the holy moly, so we can kill it. The output of my project will bring a step forward in treating melanoma, a step closer to save many more lives. Thank you.
Adjusting my stuff here. Okay. We have our, and I will. Our last presenter is from the Department of Biology, Andrea Beal, and I know that her advisor is in the audience somewhere, Dr. Matt Hale in the middle there. He's recording as well. And now we're going to talk about a different topic. We're going to go deep into the sea. I'm ready when you are ready.
I want to save these unique animals from extinction. Every year, we lose hundreds to thousands of species, and some scientists are calling it the 6th mass extinction on Earth. Seahorses and pipefish belong to a group of related organisms from which there are several endangered species. One of the major factors threatening these species is climate change. Climate change will have drastic effects on nearshore marine environments, exactly where these guys are found. Some of the predicted changes will be salinity and temperature fluctuations. This will affect the way they breathe and the way their cells need to function in order for them to survive. So when their environment changes, their whole bodies are subjected to this change. If their cells can't adapt, then they aren't going to make it. For me to protect them from extinction, I need to know if they can adapt to a new or changing environment. The way that I do this is through genetics. By studying their DNA, I can learn a lot about how they're surviving in their current environment and whether or not they can adapt to a new or changing environment. For my thesis, I'm looking at expressed genes of Gulf pipefish. Expressed genes are genes that the body was actually using when I sampled them. It's kind of like taking a snapshot of what the body was doing at that very moment. I then process and analyze my samples to create this huge data set of all the expressed genes that I find. This data set then becomes the foundation for future genetics work to come in, and we can start to decipher whether or not these species can adapt to a new or changing environment, and if they'll keep up with climate change. My research is the first step towards saving beautiful diversity like these seahorses and pipefish.
I think I'm going to bring all 6 contestants up here. I want to thank you for doing this, and because this is challenging, right? This is something that's not easy to do. This is something that we often try to, well, you know, one of the most common things that people hate to do is public speaking, right? That's on the top of the list. It also is on the top of the list of what, or oral communication is on the top of the list what employers want our students to be able to do or have a better ability at doing. So I want to thank you guys for, did you color coordinate? All wearing black. Wow. Okay, that's pretty nifty. I didn't know that. Some of you went to workshops that we had this semester, and I appreciate that you did that. I think you did a great job throughout the competition, and now we just look forward to what the judges and what the audience are going to say. But before we do that, I want to point out at least 2 people. There might be more, but there's. I want to point to. We had this competition in the spring, and I thought I saw Joe Kimball here. There he is. There's the winner of the spring competition, also from my department. And I also want to point to the dean of our college, Dr. Phil Hartman, who is also here today. And once I memorize all your names, I'll be presenting all of you. No. Okay, so with that, I'll ask you to sit down again, and for you to cast your vote, and when you're done, we'll just pass the ballot into the direction of Debbie over there, to your left. Okay. So the judges have discussed things. They were deadlocked, actually. I had to go in there and push them around a little bit. No, I didn't. So I'm going to ask Bill Bennett, who serves as the chair of the judging committee here, judging panel, to present the awards.
Yeah.
With the assistance of Debbie.
We're going to give out these fake checks. I don't think you should take these to the bank and try to get them. It represents something that you are going to get. We really enjoyed doing this. The 3 of us had a little trouble with this because we really felt like all these talks were superb, and we just want to congratulate you on your great preparation and the good job that you did up here under what I think is quite a bit of pressure. I really appreciate what you did. Our runner-up on the judging is Andrea Beal. What are they struck? Pipefish. Which we thought was a really good presentation and shows promise for helping these organisms survive.
Thank you.
Our first prize goes to Hung Doan. It's one. I'm sorry, my mistake. So you were our first prize. We really appreciate it and enjoyed your talk. I'm going to get this. The People's Choice. This is the one that you picked as the voting of the group here, and I think you probably did a fairly good job because the winner of this is Hung Doan.
Thank you, Bill. Thank you so much for helping out. Thank you, Molly. Thank you, Roby. Thanks to all of you coming here on a Saturday. It was raining. It was threatening that we, going to be rained out or something. But I have one more slide. I think. Go Frogs. Yeah.